Now let's talk about thermodynamic equilibrium. A system is said to exist in a state of thermodynamic equilibrium if there is no change in its macroscopic properties. Alright, so this is a very basic definition of a system in thermodynamic equilibrium. And the system should be isolated from its surroundings. Okay, so one more condition is, the first is no change in macroscopic properties, and it should be isolated from its surroundings. Alright, from its surroundings. Now, if you talk about an isolated system, it will reach a state of thermodynamic equilibrium in a certain amount of time or in a finite time. But once it exists in a state of equilibrium, it cannot depart from that state of equilibrium spontaneously. So this word spontaneously comes into the picture now. Spontaneous, that is in very less time. So when you have a system in equilibrium, it will take a finite amount of time to reach that equilibrium state, and it cannot depart from that equilibrium state spontaneously. Therefore, there can be no spontaneous change in any macroscopic property if the system is in thermodynamic equilibrium. Let's note this point, that is, no spontaneous change in macroscopic property can occur. No spontaneous change in macroscopic properties can occur if the system exists in thermodynamic equilibrium. If system exists in thermodynamic equilibrium. Now, what is this thermodynamic equilibrium? Now, system is said to be in thermodynamic equilibrium if the system has three types of equilibrium simultaneously. The first equilibrium is it should have mechanical equilibrium. The second one, it should have a chemical equilibrium. Alright. And the third one, it should have a thermal equilibrium. So when the system has mechanical plus chemical plus thermal, then the total condition of the system is said to be under thermodynamic equilibrium. Alright. Now we all know what do we mean by mechanical equilibrium. By mechanical equilibrium means that there are no unbalanced forces in the system. No unbalanced forces. Alright. And if we talk about chemical equilibrium, in chemical equilibrium we can say that the rate of change, or you can say the rate of forward reaction, is equal to the rate of backward reaction. Then you get a chemical equilibrium. Rate of forward reaction, okay, is equal to the rate of backward reaction. So by this we mean to say that as soon as the reactants, they transform into products, at the same time the products, they decompose back into the reactants. So this is a chemical equilibrium reaction. Next comes the thermal equilibrium. You have two bodies, body A and body B. The temperature of the body A is, let us say, 100 degrees Celsius, and the temperature of the body B is also 100 degrees Celsius. So if the temperature of the two bodies is same, there can be no heat transfer, there can be no energy interaction between these two bodies. So the condition of having the same temperature between two systems or between two bodies is said to we called a thermal equilibrium. Thermal equilibrium means same temperature. Alright, so when you have these three equilibriums coexisting simultaneously, the system is said to have thermodynamic equilibrium. So I hope this was a very easy topic for you to understand, and the more important thing to note down here is that once a system attains a thermodynamic equilibrium state, then it cannot spontaneously change its macroscopic property. Okay, so this was a very brief intro about the thermodynamic equilibrium. Now let's talk about a very important topic that comes after the thermodynamic equilibrium, is that of a quasi-static process.